In a previous video, we created a requirements document along with several requirements, and then we elaborated those requirements into a series of examples in given, when, then syntax. So you see here, as a homeowner, I want to be able to catalog my specimens, so I'll remember what I planted. Then we have several different examples that help to elaborate this. Both the happy path, for example, where we are saving a very specific eastern redbud, and also some edge cases like when we're searching for data that does not exist. So in this video, we're going to describe behavior-driven design and test-driven design and consider an approach we can use where we use this requirements document as a script to write some tests. So first, let's discover what behavior-driven design and test-driven design is. So in a nutshell, what is behavior-driven design? Well, we started with test-driven design sometime around the turn of the century. And test-driven design, really good idea. Behavior-driven design is kind of an extension or an elaboration of test-driven design. I'll talk a little bit about the similarities and differences throughout this video series. So test-driven design means we write tests before we write code. The tests were typically written by software developers. With behavior-driven design, everybody gets input into the test. We start with a requirements document in the format, as a user, I want some feature so that I can get some benefit. Now those square brackets you'll replace with the name of the user, what the feature is, and what the benefit is that the user will get from that feature. Next, we elaborate into a series of examples in given, when, then syntax. When I say elaborate, I mean any stakeholder, developer, QA, business analyst, project manager, business owner, product owner, anybody. Because we all understand what given, when, then means in the English language, if we speak English. So we can all come up with these examples. Now, why is that important? It's important because many people will consider all of the things that need to be tested, where one person might not get that level of coverage and might say, yeah, I've covered my code 100%, but maybe that code coverage is only in happy path, not including the edge cases. So it's a ubiquitous language where everyone contributes. After we've written them into the document, as we've done here, so you'll see we have our as a user interested in plants and so on and so forth, and then we have our series of given, when, thens. Next thing we'll do is create a unit test that matches that given, when, then, and this is where the developer takes over, but because we've all contributed, everybody has input into the test. So why do we want behavior-driven design and more specifically test-driven design? Well, one rule of nature, the first thing you do never gets cut when you're running out of time. The last thing you do is what gets cut when you're running out of time. And in a traditional waterfall method, typically testing is the last thing that's done. So by moving testing first, we ensure that testing happens. Now further, test-driven design, and specifically unit testing, is a code review on your own code. A lot of times I've heard people tell me that they don't do unit testing because it takes too long. And then I inquire more and more and more, and it's not the fact of the unit testing. It's the fact that the code base that they're writing is not up to par. It's inefficient. And so that's reflected by having a unit test that takes a long time to write. If you start by writing the unit test, you're more likely to write code that is efficient, that doesn't have multiple nested if tests and other things that tend to be hard to unit test. Finally, I want to quote a book written by Philip B. Crosby in the 1980s called Quality is Free. Now think about that for a minute. Sometimes when schedules get tight, we tend to try to cut quality. We say, oh, we don't need to do code reviews, we don't need to do design reviews, and we don't need to do any unit testing, we just need to get this shipped. But the problem is, when you look with that approach, you end up building something called technical debt, a term coined by Ward Cunningham. Technical debt means that you basically, when you do something that's not optimal, you end up taking out a loan, and you're paying interest on that debt until you optimize your work. Sometimes this is okay if you need to do a minimum viable product, but if left unchecked for an extended period, you end up spending all your time spending interest on that technical debt and not actually writing new features. In other words, if you write a low-quality application, you end up paying a lot in maintenance and support costs that cripples you and makes you unable to continue and write new features and the like. So what are the steps that we need for behavior-driven design? Let's start with the requirements document, and let's elaborate it into our examples in given, when, then format. Then developers write the unit tests. Then we run the test knowing it will fail because we've written the test first. Then we build the classes, we put our logic in those classes, then we run the test again, and we continue iterating on these last two steps until our tests pass. So, why is quality important? I go back to my days in college when I worked in retail at a Radio Shack. And at that time, Radio Shack sold software in the back of the store that was kind of like generic knockoff software. And these purchases were independent. Somebody might buy a Radio Shack tax program for $5 one day, realize it doesn't do what they wanted to do, throw it away. The next day somebody goes and buys the same software and doesn't know about the first customer's bad experience with the software. You could get away with quality issues in the 80s and 90s more than you could now. Nowadays, your publicly viewable rating is your biggest asset. It's the biggest thing that is selling your program or convincing people to download your program. And keep in mind how ratings happen. Have you ever rated something 3 out of 5? Have you ever gone to a restaurant and said, boy, that was the most average cheeseburger I've ever had. I can't wait to go rate it. The truth is you tend to rate things either when you're very happy or very unhappy. Ratings are very much skewed to either a 1 or a 5, nothing in the middle. So if you have quality issues in your application, that will quickly be reflected in your App Store ratings, which is the biggest asset that you have. So with that as a primer, we'll jump right in to a few hands-on examples of test-driven design in the next few videos. I look forward to seeing you then. Thank you.